In this video, let's expand our understanding of expressions by practicing translating verbal expressions to variable expressions together. In questions 1 through 10, let's go ahead and represent each of the following sentences as an algebraic expression, where a number is going to be represented by the letter or the variable x. All right, in number 1, we have a number more than 2. So keep in mind this, a number here is going to be x, right? So it's a number more than 2. More than just means we are adding. So we're going to take this number of 2, and it's going to be a number more than that. So we're going to go ahead and add on x after that. All right, so whatever x is, or a number, it's going to be that much more than 2. In number 2, we have 9 times a number. So again, a number here, that's going to be our x. So it's going to be 9 times that number. So you can write it as 9 multiplied by that number of x. But again, if you have 9 times x, you could also go ahead and just simplify this and say this is going to be 9x, just because that means multiplication anyway. All right. For number 3, we have 3 minus a number. So again, a number is going to be x here. So it's going to be 3 minus that. So we're just going to go ahead and write 3 minus whatever that number is. We're going to say it's going to be x. In number 4, we have a quotient. Keep in mind that quotient means we are dividing. So we have the quotient of a number, which is x, and the number 9. So you could write it like this, where you have a quotient, say x divided by 9. This is one way you could write it. Another way that we could write it that we'll see oftentimes in algebra is we're going to have it written as a quotient, like a fraction. So we're going to have x over 9, which is also the same thing, just written in fraction form instead. In number 5, we have 7 is decreased by a number. So this is x right over here. And 7 is being decreased by that number. So if it's decreased by 5, you would subtract 5. If it's decreased by 10, you would take away 10. But in this case, we don't know what we're decreasing by. We're decreased by this value of x. So we have 7 minus x. All right. For number 6, let's see, we have a number is being increased by 1. So here is x, it's a number, and that is going to be increased by 1. So that means we're going to add on 1 afterwards. So it's being increased by 1. So we'll go ahead and write plus 1 here. In number 7, we see that a number is being subtracted from 5. So if it's being subtracted from 5, that means we're starting with 5, and then we're subtracting that number from it. So that's going to be x is going to be taken away from that 5. Okay. For number 8, we have the quotient of 4 and a number. So keep in mind that quotient means we are dividing. So we're dividing 4 and this number here. So you can write this as 4 divided by that number. We can go ahead and say that's going to be x. Remember from earlier, we can, instead of writing using the division sign, you could also write it as a fraction and say it's going to be 4 over x. And this is going to be representing the same expression here. For number 9, we have 8 is subtracted from a number. So here is a number, that's going to be x. 8 is being subtracted from it, right? So that means that we have this x here, and we're going to be taking away 8 from that number. So when it says from, that's going to be 8 is being taken away from it. So it's the 8 minus 8 is written afterwards, okay? For number 10, we see a number is going to be raised to the 4th power. So this a number here is going to be x. When you raise something to a power, that means we're writing something using an exponent, right? So it's going to be raised to the 4th power. So that exponent up here is going to be 4. So that would be the expression. All right, let's go ahead and check out numbers 11 through 18. And for these particular problems, for a number, we're going to use the variable y instead of x. So number 11, we have the difference of 5 and the product of 3 and a number. So let's see, let's identify a couple quick things. We have a number right over here, and then we have the difference of what? We have the difference of 5 and the product of 3 and a number. So we see the word and we're finding the difference of 5 and what? So it's going to be 5 minus, just because difference means subtraction. So it's 5 and what's the difference of? It's going to be the product of 3 and a number. So afterwards, it's going to be 3 multiplied by y, just because product means we're multiplying here, right? So we have the difference means subtraction here, right? And then it's difference of what? It's 5, which is before the word and then we have the product of 3 and a number. So here's the product of 3 and a number. In number 12, we have the cube of the sum of a number and 4. So here is a number right over here. And let's see, if we're going ahead and find the sum means we're adding two things. We're adding a number and 4. So find that word and here, that kind of separates the two things we're adding. So let's see, we have a number, which is y, and we're finding the sum of that and 4. So here's the sum right over here. Y plus 4 is the sum. I'm going to go ahead and kind of show you like this. The sum of a number and 4, that's what this is right here. And then afterwards, we're supposed to find the cube of this thing, right? We're supposed to find the cube of that sum. So you're going to have to find the sum and then cube it here. So if we go ahead and put parentheses in, that means we're going to find the sum first, and then we're going to take the cube of that thing afterwards. So the parentheses will help us control the order of operations here. In number 13, we have twice the sum of a number and 5. So we have a number, that's going to be y here. And we see the word sum again, so sum means we're adding. So what are we going to be adding? It's going to be a number and 5. So I think it's always good to kind of find out where that word and is here. And so let's see, we're going to have y plus 5. So right here, you can see this y plus 5. This right here is the sum of a number and 5. That's right here. Okay, but then we have to find twice whatever that is. Well, if you just put a 2 out here in front, that means we're going to only multiply the y by 2, but we're supposed to be taking twice the sum. So we'd have to find whatever the sum is and then double whatever that is. So multiply by 2 afterwards. So the parentheses are going to help there again as well. So in number 14, we have the product of 8 and the sum of a number and 9. So we have a number right over here. And so what do we have? We have the product of 8 and the sum of a number and 9. So there's 2 ands here, but I'm going to go ahead and always take care of the addition or subtraction first, just because if we set it up that way, then we can group things as necessary. So we know we're multiplying 8 by something, but what is that something? Well, we have the sum. Let's just look at this part right now, right? The sum of a number and 9. So sum means we are going to be adding. And what are we adding? A number and 9. So here's the word and. Let's go ahead and write here, we have the sum of a number, so that's going to be y plus 9. Okay, so we have right here the sum of a number 9, that's right over here. Okay, and then what are we supposed to do? We're supposed to find the product. Product means we are multiplying the product of what? 8 and whatever this thing is right over here. So let's go ahead and see, we have another word and, which means the two things we're multiplying here are going to be 8 and then the sum of a number and 9, right? So the product means we're multiplying. This is 8 times. Here's the product. It's 8 times this whole thing, right? But then what's the sum? The sum is that y plus 9 part. So this sum is right inside here, and this 8 is being multiplied by this whole sum afterwards. Here's number 15. In number 15, we have 5 less than 6 times a number. So let's see, a number here is just going to be x, and it's 5 less than 6 times a number. So 5 less than something means, this 5 less than means we're going to be taking away 5 from something, right? So we're going to go ahead and write minus 5. It's 5 less than something. So it's 5 less than what? It's 5 less than 6 times a number. So what's that number going to be? Well, it's just going to be 6 multiplied by y, right? So this 6 times a number, this is right over here, okay? And it's 5 less than that, and that's this minus 5 right over here. In number 16, we have the product of 7 and the square of a number. So let's see, product means we are multiplying. What are we multiplying? Well, it's going to be 7 and then we have the square of a number. So that's raising something to the second power there, right? So let's go ahead and see here. We have a number, which is going to be y. And we're going to go ahead and just square that first, right? So we have the square of a number. Let's just look at that part first. If we square a number, that's just going to be this y raised to the second power. That means we are squaring it. And we're supposed to be finding the product, which means we're multiplying the product of 7 and whatever we just wrote there. So how do you write the product of 7 and this? We could just write 7 multiplied by y to the second power, or 7y squared. So we have the product of 7 and the square of a number. So here's the 7 and here's the square of a number, and we're finding the product of them because we're multiplying them together. In number 17, we have the product of 4 and the difference of a number and 2. So let's see, product means we're going to be multiplying 4 by something. What are we multiplying 4 by? Well, it's going to be the difference, which means subtraction of a number and 2. So we have a number, that's going to be y. And let's see here, if we go ahead and just look at the difference of a number and 2, we can see that before the word and here, we have 4 multiplied by. And what are we multiplying 4 by? It's going to be the difference of this. So make sure we put this in parentheses just because 4 has to multiply by the entire difference, right? So if we're going to go and find the difference here, that's going to be y minus 2. That's the difference between a number and 2. And then we're going to go ahead and multiply that by 4 because we're finding the product here. All right, so this 4 is before the word and means we're finding the product between these two things. So there's multiplication here, right? And then what's afterwards, it's the difference of the number and 2. So that's this part right over here. That's the difference. Okay. In number 18, we have 3 less than the quotient of 7 and a number. So here is a number at the end here. It's 3 less than. So if we have 3 less than something, that means we're going to take away 3 from it. Quotient means we are going to be dividing. So let's see here. It's going to be 3 less than. So we know it's going to be minus 3 at the end. Okay. And then we have the quotient of 7 and a number. So a quotient, you can write it as a division problem. So it's quotient of 7 and a number. So I'm going to say it's 7 divided by this y. So this would be one way you could write it. So we have 3 less than, which is right over here. We're taking away 3 from what? The quotient of 7 and a number. So that's right over here. That's the division. You could also rewrite this using a fraction bar, as you'll see oftentimes in algebra, but we'll write 7 over y. That's the quotient as well. And then you would take away 3 afterwards. So that would be another way we could write it. All right, here is number 19 through 24. We're going to go ahead and represent the following sentence as an algebraic expression where a number is the letter m this time, then evaluate the expression when m is 4 and then when m is -3. So a couple hypothetical values for m. All right, so for 19, we have 4 more than the product of 7 and a number. So a number here is going to be my letter m. So I'm going to go ahead and think about that. So it's 4 more than, we're going to add on 4 to the product of 7 and a number. So I think our expression here is going to be 7 multiplied by m. So, and it's going to be 4 more than whatever that is, right? So 4 more than means we're going to be adding it on afterwards. Product means we're multiplying 7 and m. So that's going to be our expression. Now then they're saying, what if m is 4 and m is -3? So we're going to go ahead and say here, we're going to say let m equals +4 here. So if we let m equals +4, it's going to be 7 multiplied by 4 here. And then we would add on 4 afterwards, right? So 7 times 4, that's going to be 28. If we go ahead and just follow the order of operations. So that's going to be 28 plus 4. And if you do 28 plus 4, that's going to be equal to 32. Right, so that's if m is equal to 4. I'm actually just going to go ahead and highlight that real quick so it's a little bit more clear. And then let's see if we're going to go ahead and let m equal -3 now. So let m equal -3. Again, this is just hypothetical values that we're trying out here. And then if we go ahead and let m equal -3, instead this time it's just going to be 7 multiplied by -3. And we're going to go ahead and add on 4 afterwards. So if m is -3, we're going to get a different value here, I think, right? So 7 times -3 is going to be -21. -21 plus 4, that's going to be equal to -17. So you can see if m changes values, then the value of the expression is also going to change. All right, number 20, we have 5 less than the quotient of -16 and a number. So if we have 5 less than something, we're going to be taking away 5 from something, right? We're taking away 5 from the quotient. Quotient means division. So we're going to have -16 divided by that number m here. That's our variable, right? So this would be our expression. And you could write it using the division sign too, but I think it's good to practice using a fraction bar. All right, so let's go ahead and let m equal a couple different things here. Let's let m equal, what's the first value we're going to say for m? I think we said it was going to be +4 here, right? So we're going to let m equals +4, and then in a moment we'll also let m equal -3. That was the 2 values there, right? All right, so if m is equal to +4 here, we're going to say this is going to be -16 divided by this +4. And then we're going to go ahead and take away 5 afterwards. Following the order of operation, let's go ahead and just take care of this division. So that's going to be -4. And then -4 minus 5 is the same thing as -4 plus -5. And that's going to be equal to -9. So if m was +4, this expression would be equal to -9. And then let's see, what if m is -3? If m is -3, we'll have -16 over this -3. And then if we take away 5 on afterwards, let's see, if we do this first division, let's see, I think the negative divided by negative is going to be a positive, and then we're going to have a remainder here. So we're going to have here, I think, 5 and 1/3. So it's +5 and 1/3, take away 5. Now 5 and 1/3 take away 5 is just going to be +1/3 here. Okay, so if we go ahead and say m is -3, then this expression would be equal to +1/3. For number 21, we have the product of -2 and the difference of a number and 7. So here is a number, and it's going to be the product of -2 and that difference. So keep in mind, if we take the difference of a number and that's 7, we're going to go ahead and write the difference first. So the difference is going to be m minus 7, so that's the difference. And it's got to be the product of -2 and that entire difference. So -2 is going to multiply by that difference here. All right, so this would be our algebraic expression. And now let's go ahead and evaluate the expression based on a couple different values for m, or hypothetical values. So when m is positive 4, we're going to have negative 2 multiplied by this positive 4, subtracting 7 here, right? Now, following the order of operations, you can use a distributive property if you want to, but I don't think we need to here. 4 minus 7 is negative 3, so we're going to have negative 2 multiplied by negative 3 here. And then we have negative 2 times negative 3, that's just going to equal positive 6. Now, what if m is negative 3? Well, it's going to be negative 2 multiplied by this negative 3 minus 7. All right. And again, if you follow the order of operations, negative 3 minus the 7 here, that's going to be negative 10. So we're going to have negative 2 multiplied by negative 10. And if you multiply negative 2 and negative 10, we're going to get positive 20 for the value of this expression. All right, here is number 22. In 22, we have the quotient of the sum of a number and 8 and 2. In number 22, we have the quotient of the sum of a number and 8 and 2. So this one's a little bit different because we have the wording like this, but we have the quotient, which means we're dividing. We're dividing what two things? Well, it's going to be the sum of a number and 8. So this is the first thing we're dividing. The second thing we're dividing is 2, or rather the what's before the division sign and what's after the division sign. So just take a look at where the word and is here, okay? So the sum of a number and 8, so I'm going to go ahead and write it like this. We have a number, the sum of a number and 8, so we're going to write that as m plus 8 here. M plus 8, that's the sum of a number and 8, and it's a quotient of that and 2. So you could write this in parentheses like this and then write divided by 2, but more oftentimes you'll see it written like this, where you have the m plus 8 and it's going to be over 2. Right, and it's implied, remember that fraction bars imply that there's a grouping symbol, that this would be grouped anyway. So more than likely you would see it written as a fraction instead, so practice writing that. Now let's go ahead and find the value of this expression given that m is 4 and m is negative 3. So let's say m is 4. If m is 4, let's see what this expression would be equal to. It'd be 4 plus this 8, and it's going to be over this 2. All right, if we're going to go ahead and follow the order of operations here, we would take this 4 plus 8 and do that first. 4 plus 8, that would be equal to 12. So that's going to be 12 over 2. And if you go ahead and just divide this 12 and 2 here, 12 divided by 2, that's going to be equal to 6. Okay, now what if m is negative 3? A little different here. We'll have negative 3 plus this 8, and that's going to be over this 2 here. If we go ahead and solve the numerator first here, negative 3 plus the 8 is going to be 5. So we have 5 over 2. Then if we do 5 divided by 2 here, you can do it as a fraction or a decimal. I'm going to just use it as a fraction here, or write it as a fraction. It's going to be 2.5. Of course, you could leave it as improper fraction too, I guess, but I'm going to write it as a mixed number just to practice. For 23 here, let's go ahead and find the difference of the negative 9 and the cube of a number. I guess technically this the doesn't need to be here, so if that's confusing, sorry, but you can just ignore that. So it's a difference of the negative 9 and the cube of a number. So where is the a number? That's going to be at the end here. So it's the difference of this negative 9 and the cube of a number. So difference means we're subtracting. What two things are we subtracting? We're subtracting negative 9 and the cube of the number here. So let's go ahead and write negative 9 minus, and how do you cube a number? If you cube a number, that's going to be m in this case raised to the third power, whatever that number is going to be. So this right here would be our expression. And now let's go ahead and evaluate it given some particular values here. So let's say we have negative 9, and it's going to be minus, and then this is going to be 4 raised to the third power. Okay. Now, actually, I like highlighting these more than I liked, I think, underlining earlier. It might be a little less confusing. So if we do this 4 to the third power, that's 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So we're going to have negative 9 minus 64 here. And if we go ahead and figure out what negative 9 minus 64 is, that's negative 9 plus negative 64. So that's going to be negative 73. All right, so that would be the value of this expression if m is equal to positive 4. Now, what if m is negative 3? If m is negative 3, we're going to have negative 9 minus. Now, be careful with this one. We should take this negative 3 and put it in parentheses here, just because that whole negative 3 is going to be raised to the third power. So if you don't put the parentheses, you may lose track of some negatives there. So again, it's negative 3 raised to the third power. Insert those parentheses. That's negative 3 times negative 3 times negative 3. So 3 times 3 is 9. 9 times 3 is 27. But it's negative 27 because there's 3 negatives. So we're going to have negative 9 minus, and I'm going to go ahead and write negative 27. That's what the negative 3 in parentheses cubed is equal to. Now this negative 9 minus this negative 27, if you rewrite that as a sum, it's going to be negative 9 plus 27, which is just 27 minus 9, and that's going to be 18. So that would be the value of this expression if m is equal to negative 3. I'm just going to go ahead and X out this the there because it's kind of confusing. In 24, we have 8 less than the product of a number and negative 5. So we have here a number that's going to be our m, and then it's going to be 8 less than the product of a number and negative 5. So for the product here of a number and negative 5, it's going to be m times negative 5, but we can write that as this negative 5 as a coefficient. So we can write negative 5m. This definitely represents the product of those two things. Using the commutative property of multiplication, you can rearrange that. And then we can go ahead and take away 8 afterwards, right? So it's 8 less than it, so that would be our expression. All right, now that we know what the expression is, let's go ahead and evaluate it with a couple different hypothetical values. So we have this negative 5 multiplied by 4. So let's go ahead and substitute in 4 in for m and take away 8 afterwards. Now if we go ahead and follow the order of operations, negative 5 times 4 is going to be negative 20. So we have negative 20 minus 8. And a negative 20 minus 8, that's just going to be equal to negative 28. All right, now what if m is negative 3? If m is negative 3, let's just rewrite the expression, but just swap out negative 3 instead of the 4 there. So it's negative 5 times negative 3 and then minus 8. And then negative 5 times negative 3, that's going to be positive 15. So positive 15 minus 8, that's just going to be equal to positive 7. All right, so there you have 24 different practice problems where we went ahead and took some verbal expressions and translated them into algebraic ones. And then when we ended here, we also practiced evaluating these expressions given some hypothetical values for the variables. All right, just for good measure here, I think I'm going to go ahead and just change some of these or rewrite these so that they're highlighted. I think sometimes the little underlines might be a little confusing here. So hopefully going back and highlighting some of these might be a little bit more clear. And the underlines can just maybe back them up a little bit, but maybe the highlighting is more clear or less clear. I don't know, you can tell me what you prefer, but I think this might be a little bit more organized. All right, so that wraps up this video. If you found it helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.